So laws of exponents, law number 1, a to the m times b to the n. How about we do this? Now we can actually do something with it. Law number 1, a to the m times a to the n. What does that equal? Like bases, keep the base. What do you do with the exponents? Add them. So it's a to the m plus n. Number 2, okay, like bases. I was getting tired when I wrote these yesterday. Okay, law number 2, like bases, you divide them. A to the m divided by a to the n, what does that equal? Well, same base, keep the base, and then a to the m minus n, right? Okay, number 3, exponent on the inside, exponent on the outside, a to the m to the n. Keep the base, multiply the exponents, right? Number 4, what if you have a times b to the m power? A times b in parentheses to the m power. What does that equal? Yep. And now the operation's got to be multiplication or division. It works for division too. A to the m times b to the m. So, I mean, you could say the same thing for division. Well, okay, it's not exactly the same thing, but same idea, right? Splits up. Does it work for addition or subtraction? Does not split up over addition and subtraction. Think of a plus b quantity squared. It does not equal a squared plus b squared, does it? It equals a squared plus 2ab plus b squared. So it does not split up over addition or subtraction. What about a to the 1 power? Hey, a to the 0 power. A to the 0 power is 1. It is true. Okay. So, guess what? The laws of exponents hold if the exponents are written in terms of fractions. So let's try the laws of exponents out on expressions that have fractions in the exponents. So let's do, in part A, 5 to the 2/3 times 5 to the 1/2. Like bases, what do? We're multiplying. You keep the base and add the exponents. So you get 5 to the, well, 2/3 plus 1/2. That was property number 1, right? All right, well, what do we need to add 2/3 plus 1/2? LCDs. So what's the LCD between 3 and 2? It's a little scratch work here. What is 2/3 plus 1/2? What am I going to multiply 2/3 by to get the denominator of 6? 2 both times. And 1/2? I'm going to multiply by 3, right? So what do I get? I get 4/6 plus, 3/6? So what do I get when I add those together? 7/6, don't I? Okay, so this is scratch work. So how am I going to write the final answer in blue? Just 5 to the 7/6 power. Does that make sense to you? You definitely are not going to want to write 7/6 as 1 1/6, right? Not a mixed numeral. Yeah. In part B, we have 9 to the 7/11 divided by 9 to the negative 2/11. So which of the rules up here applies? Rule number 2, right? We're dividing like bases, so we keep the base and subtract the bottom exponent from the top exponent to get our new exponent. So that means that we can keep, what's the base in this case? 9, and we can take the 7/11 minus the negative 2/11 as our new exponent. But what happens when you subtract the negative? You end up adding. And the good news is we have common denominators already, so what do we get? 9 to the, just add 7/11 plus 2/11, what do you get? 9/11. 9 to the 9/11. And we're going to stop there. I mean, you could get a decimal number for that on your calculator if you want, but that's not what we're going for here. Okay, so part C, we have a to the negative 3/2 inside parentheses, and then 2/9 on the outside. So does anybody recognize which property this is? It's number 3, isn't it? Exponent on the inside, exponent on the outside. So what does the rule say? Keep the base and multiply the exponents. So in this case, the base is a, and we're going to multiply -3/2 times 2/9. We have to simplify that, but does everybody see the rule that I applied? Number 3? Okay, well, let's multiply -3/2 times 2/9. Yeah, if you divide before you multiply, it's easier though, isn't it? So does everybody see you'll get -3/9, which is the same as what? So a to the -3/9 is the same as a to the -1/3. What if you don't allow negative exponents? How would you write it? 1 over a to the +1/3. So that's how we'll take our answer. Now there's nothing wrong with a to the -1/3. When we get rid of the negative exponent, we're just getting practice in reminding ourselves what the negative exponent means. In some ways, I think a to the -1/3 looks better than 1 over a to the 1/3 because there's not as many symbols.